Next, let's consider the accessor and mutator methods of the class. These are specific methods which either access or get or mutate or set one instance variable's value, and we often refer to these as getters or setters. Again, in a well-established Java naming convention, these methods begin with the word get for accessors and set for mutators, and are followed by the name of the instance variable to which they are applied. So why do we have accessors and mutators anyway? Well, as we said earlier, in a well-designed Java class, the instance variables are typically declared as private, and public accessors and mutators provide the only outside access to this data. As this figure suggests, these methods provide the internal pipelines for the outside world to and from this instance data. One guiding principle in object-oriented programming is that a class manages, or is responsible for, all of its own data. Accessors and mutators enable this by providing well-controlled pathways to and from the instance variables of a class. Here are all of the accessors for the CS12 date class. The class has 4 integer month, day, year, and text instance variables, so it has 4 corresponding get methods, one for each. Each accessor takes no inputs and simply returns the value of its instance variable, which is of the type indicated here. By convention, all accessors begin with the word get, followed by their related instance variable. And notice that despite each of those instance variables beginning with a lowercase letter, their accessors maintain camel case naming by capitalizing the first letter of those otherwise lowercase instance variables. Here are all of the mutators for the CS12 date class. Here it's the same thing, but in reverse. Since we have 4 instance variables, we have a mutator for each one. Each one's role is simply to accept some input data of the corresponding data type and update that instance variable to the specified value. They return no value to the calling program, so all mutators are of type void. If the provided values are somehow invalid, the resulting actions are as noted here in this API. Again, by convention, all mutators begin with the word set, and the instance variable name is capitalized to maintain camel case naming. We've touched upon this in passing already, but there is a key concept in object-oriented programming called encapsulation, which states that in a well-designed class, all the instance variables should be private and should only be accessible by public accessors and mutators, which are simply methods of that class. In other words, the data is guarded and protected at all costs, and there are specific, well-defined channels to get at that data. This kind of data hiding is important. It prohibits the data from being changed randomly or willy-nilly from any outside direction. It also allows for data validity checking, so that only allowable values may be assigned to any class data. We'll see how this works later in the course when we start implementing our own classes. As a simple analogy, I like to think of the example of a restaurant. You don't just randomly walk in off the street or through the back door and start cooking food. Well, maybe in the place I worked at in high school you did. Patrons in general are restricted to ordering off a menu of options and via a server, both of which serve as the well-defined interface to the kitchen. Running a restaurant like this lets you keep control of your inventory, and it prevents general chaos in the kitchen. I'm not suggesting that writing good object-oriented software is like working in a restaurant, but I think you get the analogy here. Here's another more software-specific example. This one is taken from the Oracle Java Trail, a link to which should be found in this week's lecture materials. Let's imagine the example of a bicycle. And let's say we have a Java class which describes a bicycle. A bicycle might have such characteristics, or instance variables, such as pedaling cadence, speed, and gear. Taken together, this set of instance variables fully describes the state of the bicycle, but we can't change these instance variables directly. They are at the core of our bicycle class, as seen here, and they are surrounded by a hard protective shell of methods, or actions, as shown here. So we don't change the instance variables directly, but rather they change as a result of several typical bicycling actions, as seen here. Note that these are now not mutators, but rather some bicycling actions or methods of the class. For example, suppose we want to change gears and go to a higher gear. As a result of calling such a method, presumably our speed would increase while our pedaling RPMs would go down, and of course our gear number would go up. Or let's say we want to brake. If we call that method, presumably our speed would decrease suddenly, as would our pedaling RPM, while our gear remains unchanged. Hopefully you get the idea here. In a Java class, the instance variables are central and they are private, and their values can only be changed by the use of public methods, which are the outside interfaces to them.